Alright, so here's our next set of lessons on factoring. It's more factoring, as you can see right up there by the title. And specifically, we're talking about the trinomials. So we covered most of that factoring flowchart that I made for you, except for when it has three terms. Now, even though there's just one objective to factor trinomials, this is actually going to come in three parts. Trinomials, three parts. Anyway, so we'll have stuff like perfect square trinomials, or if it's not that, maybe the leading coefficient is 1, or if it's not 1, maybe it's something else, and those are the three cases that we're going to have to consider here. So before we do that, let's take a look at this warm-up question. So let p and q be two integers such that p times q is equal to negative 84, and p plus q is equal to negative 5. What are the values of p and q? In other words, I'm looking for two numbers. When I multiply them together, I get negative 84. And when I add the same two numbers together, I get negative 5. So think for a second. Go ahead and pause if you need to. See if you can come up with those two numbers. Okay, so did you come up with negative 12 and 7? Those are our two numbers, because negative 12 times 7 is equal to negative 84. Okay, and then negative 12 plus 7 is equal to negative 5. So it fits both of those criteria. All right, so this is exactly what you have to ask yourself whenever you factor a trinomial. You're looking for two numbers that when you multiply them together give you a product. And whenever you add those same two numbers up, they give you some sort of sum, okay? Now, if this kind of thing is hard for you, then just make yourself a list of factors and add them or subtract them. Don't even worry about the signs. Just add them or subtract them. You can take care of the signs at the end. So here's an example of what I'm talking about. So I need to find factors of 84, and I may not even know where to start, but the first one you should always start with is simply 1 times 84. When we add those together or subtract them, I'm either going to get 85 or I'm going to get 83. Neither one of those are going to work. Okay, well 84 is a prime number, so maybe I divide it by 2. 2 and 42. Add them up, subtract them. Am I going to get 5 from that? No, I get 44 or I get 40. No, it's not going to work. Okay, so how about 3? Does 3 go into it? Sure, it goes into it 28 times. Add them up. I get 31, subtract them, 25, not going to work. Okay, so you might keep doing this until you find a pair that works. Now, something else that you can notice is that these factors have to be pretty close to each other if they're going to add up. Well, really, it's the difference, since it's negative, is going to be negative 5. So here we go. Finally, we have 7 and 12. If we were to add them together, we get 19, but if we subtract them, we're going to get 5. And we know we're going to subtract them because we have a negative product. If we have a negative product, one must be positive and one must be negative, right? Okay, so there would be our answer. Okay, so knowing that, why don't you give this second one a try? So the numbers here, well, the number that we have to factor, the p and the q, p times the q, 234 is kind of big. So see what you come up with. Go ahead, again, pause the video and see if you can come up with p times q, two numbers that multiply up to 234, and this time add up to negative 31. Did you get stuck? Did you find some factors? Well, let me tell you this. If your numbers are pretty large, if they're too large to comfortably factor maybe in your head, then try making a factor tree, and then you can take the factors, the prime factors from your factor tree, and kind of link them together to see if you can get the sum that you need. So here's the example on this one. So I have 234. Well, I know 234 is even, so it's divisible by 2. So I divide it by 2, I get 117. Okay, it's not even anymore, so 7 plus 1 is 9. 9 is divisible by 3, therefore this number is divisible by 3. Oh, it's also divisible by 9. Okay, so 9 times 13, and then of course 9 is 3 times 3. So what you want to do is you want to pair up those factors in certain ways so that you can get a sum of 31, or in this case actually negative 31. So I might have picked 13. If I pick 13 as one of my factors, the other one's 2 times 3 is 6 times 3 is 18. Is there anything that I can do with 18 and 13 in order to get 31? And the answer is yes, if I add them together. Okay, so further from this, I knew that the actual numbers 18 and 13 had to both be negative, and here's the reason why. They had to add up to a negative number, and they had to multiply to a positive. So a negative times a negative would make that a positive number. Okay, so again, these will be the things that you're going to have to consider whenever we go to factor a trinomial.